Welcome to our deep dive into transfer learning. In today's world of artificial intelligence, transfer learning has become a game changer. Instead of building models from scratch, we can now use pre-trained models as a starting point, saving time and resources. This approach is especially useful when you have limited data or want to achieve high performance quickly. Throughout this video, we'll explore what transfer learning is, why it's so powerful, and how you can apply it in your own project. Let's begin by understanding the basics and setting the stage for the exciting journey ahead. Transfer learning is a technique in machine learning where a model developed for one task is reused as the starting point for a model on a second task. This is particularly effective in deep learning, where large neural networks require vast amounts of data and computational power. By leveraging knowledge from pre-trained models, you can adapt to new but related problems with less effort. This concept has revolutionized fields like computer vision and natural language processing, making advanced AI accessible to more people and industries. Pre-trained models are trained on massive datasets and have already learned useful features. By using them, you don't have to start from zero. This saves both time and computational resources. For example, models like RaiseNet or BERT have been trained on millions of images or texts, capturing complex patterns that would be difficult to learn from a small dataset. This makes them ideal for tasks where data is scarce or expensive to collect. Let's see how this works in practice. The process of transfer learning typically involves taking a model that's already been trained on a large dataset and fine-tuning it for a new related task. For instance, you might take a model trained to recognize thousands of objects and adapt it to identify specific products in your inventory. The early layers of the model capture general features, while the later layers are adjusted to your specific needs. This approach allows you to get high accuracy with less data and effort. Transfer learning is widely used in various domains. In computer vision, it helps with image classification, object detection, and facial recognition. In natural language processing, it powers tasks like sentiment analysis, translation, and question answering. Even in audio and speech recognition, transfer learning accelerates development. By reusing knowledge from one domain, you can tackle new challenges more efficiently and effectively. Some of the most popular pre-trained models include RaiseNet, VGG, and Inception for image tasks, and BERT, GPT, and RoBERTa for text tasks. These models have been trained on massive datasets like ImageNet or large text corpora, making them powerful starting points for a wide range of applications. By choosing the right pre-trained model, you can jumpstart your project and achieve impressive results with minimal effort. One common approach in transfer learning is feature extraction. Here, you use the pre-trained model to extract useful features from your data, then train a new classifier on top. For example, you might use a pre-trained CNN to process images and then use those features for your own classification task. This method is fast and effective, especially when you have limited data for your specific problem. Fine-tuning is another key strategy in transfer learning. Instead of just using the pre-trained model as a fixed feature extractor, you continue training some or all of its layers on your new dataset. This allows the model to adapt more closely to your specific task. Fine-tuning can lead to even better performance, especially when your new task is similar to the original one the model was trained on. Transfer learning is most beneficial when you have limited labeled data for your target task, but there exists a related task with abundant data and pre-trained models. It's also useful when training from scratch would be too expensive or time-consuming. If your problem is similar to one that's already been solved, transfer learning can help you achieve great results quickly and efficiently. While transfer learning is powerful, it's not a silver bullet. If your target task is very different from the source task, the pre-trained model may not transfer well. Also, some models can be very large and require significant computational resources. It's important to evaluate whether transfer learning is suitable for your specific problem before investing time and effort. Selecting the right pre-trained model is crucial. Consider the similarity between your target task and the original task, the size of your dataset, and the computational resources available. For image tasks, models like RaiseNet or MobileNet are popular choices. For text, BERT and GPT are widely used. Matching your needs to the strengths of the model will help you get the best results. For applying transfer learning, it's important to prepare your data properly. Clean and pre-process your dataset, ensuring it matches the input format expected by the pre-trained model. For images, this might mean resizing or normalizing. For text, you may need to tokenize and encode. Good data preparation sets the foundation for successful transfer learning. Common technique in transfer learning is freezing some layers of the pre-trained model. This means keeping their weights fixed during training, so only the new layers you add are updated. Freezing layers helps retain the valuable knowledge learned from the original task, while allowing your model to adapt to the new one. It's a simple yet effective way to balance old and new information. To adapt a pre-trained model to your specific task, you often add custom layers on top. These layers are trained on your own data, allowing the model to learn task-specific features. For example, you might add a new classification layer for your unique set of categories. This customization is key to making transfer learning work for your particular problem. There are several strategies for training with transfer learning. You might start by training only the new layers, then gradually unfreeze and fine-tune more layers as needed. This staged approach helps prevent overfitting and makes the most of the pre-trained knowledge. Experimenting with different strategies can help you find the best balance for your project. After training your model, it's important to evaluate its performance. Use appropriate metrics for your task, such as accuracy, precision, recall, or F1 score. Compare results with and without transfer learning to see the impact. This evaluation helps you understand the benefits and limitations of your approach, guiding future improvements. Overfitting can be a concern in transfer learning, especially with small datasets. Techniques like data augmentation, dropout, and regularization can help. It's also important to monitor validation performance and stop training when improvements plateau. By taking these precautions, you can ensure your model generalizes well to new data. Computer vision, transfer learning is especially powerful. Pre-trained models like RaiseNet and VGG have learned to recognize a wide variety of features, from edges to complex objects. By fine-tuning these models, you can quickly adapt them to tasks like medical image analysis, product recognition, or even art classification. This flexibility has made transfer learning a standard tool in the field. Natural language processing has also been transformed by transfer learning. Models like BERT and GPT have been pre-trained on massive text corpora, learning the nuances of language. By fine-tuning these models, you can tackle tasks like sentiment analysis, summarization, or chatbot development with remarkable accuracy, even with limited labeled data. Audio and speech recognition have also benefited from transfer learning. Pre-trained models can extract features from audio signals, making it easier to build systems for speech-to-text, speaker identification, or emotion detection. This approach reduces the need for large, labeled audio datasets and speeds up development. Let's look at a practical example. Suppose you want to classify images of different types of flowers, but you only have a small dataset. By using a pre-trained model like RaiseNet, you can extract features from your images and train a new classifier on top. This approach can achieve high accuracy, even with limited data, thanks to the knowledge already embedded in the pre-trained model. For text tasks like sentiment analysis, transfer learning is equally effective. By fine-tuning a model like BERT on your specific dataset, you can quickly build a system that understands positive and negative sentiments. This is especially useful for businesses analyzing customer feedback or monitoring social media trends. In speech recognition, transfer learning allows you to build accurate models with less data. By leveraging pre-trained audio models, you can develop systems for voice commands, transcription, or even language translation. This makes advanced speech technology accessible to more developers and organizations. One of the biggest advantages of transfer learning is its effectiveness with small datasets. By starting with a model that already knows a lot about the world, you can achieve good results even when labeled data is scarce. This opens up machine learning to new applications and industries that may not have access to large datasets. Transfer learning isn't just for standard tasks. You can adapt pre-trained models to highly specific problems, like detecting rare diseases in medical images or identifying unique sounds in audio recordings. By customizing the final layers and fine-tuning, you can tackle challenges that would otherwise be out of reach. Many industries are embracing transfer learning to accelerate innovation. From healthcare to finance, companies are using pre-trained models to solve complex problems faster and more efficiently. This approach reduces development time, lowers costs, and enables organizations to stay competitive in a rapidly changing world. There are many open-source resources available for transfer learning. Libraries like TensorFlow, PyTorch, and Hugging Face provide pre-trained models and tools to get started quickly. These resources make it easier than ever to experiment with transfer learning and bring your ideas to life. Typical transfer learning workflow involves selecting a pre-trained model, preparing your data, adding custom layers, and training the model on your task. You'll also evaluate performance and fine-tune as needed. Following this workflow helps ensure a smooth and successful transfer learning project. To get the most out of transfer learning, follow best practices like starting with a well-matched pre-trained model, carefully preparing your data, and monitoring performance throughout training. Don't be afraid to experiment with different strategies and hyperparameters to find what works best for your task. Be aware of common pitfalls in transfer learning. Using a model that's too different from your task can lead to poor results. Overfitting is another risk, especially with small datasets. Always validate your model's performance and be ready to adjust your approach if needed. If you're new to transfer learning, start with simple projects and well-documented models. Many tutorials and guides are available online to help you get started. As you gain experience, you can tackle more complex tasks and customize models to fit your needs. For advanced users, techniques like domain adaptation, multitask learning, and meta-learning can further enhance transfer learning. These approaches allow models to generalize across different domains or learn multiple tasks at once, pushing the boundaries of what's possible with AI. Transfer learning is a hot topic in AI research. Scientists are constantly developing new methods to improve transferability and reduce the need for labeled data. By staying up to date with the latest research, you can apply cutting-edge techniques to your own projects. As with any AI technology, it's important to consider the ethical implications of transfer learning. Be mindful of biases in pre-trained models and ensure your applications are fair and transparent. Responsible use of transfer learning can help build trust and avoid unintended consequences. The future of transfer learning is bright. As models become more powerful and datasets grow, transfer learning will enable even more applications. We can expect to see advances in zero-shot learning, continual learning, and AI that adapts to new tasks with minimal data. The possibilities are endless. Let's recap what we've learned. Transfer learning leverages pre-trained models to solve new tasks efficiently. It's especially useful with limited data and can be applied to images, text, and audio. By following best practices and being aware of limitations, you can achieve impressive results in your projects. Ready to try transfer learning? Start by exploring open source libraries and pre-trained models. Choose a simple project, prepare your data, and experiment with different strategies. With practice, you'll quickly see the benefits and unlock new possibilities in your work. There are many resources available to help you learn more about transfer learning. Online courses, tutorials, and documentation from major libraries like TensorFlow and PyTorch provide step-by-step guidance. Community forums and research papers are also great places to deepen your understanding. The AI community is vibrant and supportive. Whether you're a beginner or an expert, you can find help and inspiration from others working with transfer learning. Sharing your experiences and learning from others can accelerate your progress and spark new ideas. Transfer learning is already making a difference in the real world. From improving medical diagnoses to powering smart assistants, its impact is growing every day. By understanding and applying transfer learning, you can be part of this exciting transformation. To succeed with transfer learning, stay curious and keep experimenting. Don't be afraid to try new models or techniques and always validate your results. With persistence and creativity, you'll unlock the full potential of transfer learning in your projects. Transfer learning is a key driver of progress in artificial intelligence. By building on existing knowledge, we can solve new problems faster and more effectively. As AI continues to evolve, transfer learning will remain at the heart of innovation. Despite its many benefits, transfer learning still faces challenges. Issues like domain mismatch, data privacy, and model interpretability require ongoing research and attention. By staying informed and proactive, you can navigate these challenges and continue to innovate. Now that you understand the basics of transfer learning, it's time to take action. Identify a problem you want to solve, find a suitable pre-trained model, and start experimenting. Each project will teach you something new and bring you closer to mastering this powerful technique. Transfer learning is transforming the way we build intelligent systems. By leveraging pre-trained models, you can achieve more with less and bring your ideas to life faster than ever before. Stay curious, keep learning, and embrace the possibilities that transfer learning offers. The future of AI is in your hands.